This video tutorial will cover creating a DEM using a LIDAR dataset, as is covered in the same chapter, Chapter 12 of the ebook, Working with LIDAR Using ArcGIS Desktop. So to get started, we're going to be in our Hopkinsville dataset again, and I'm going to set my filters to ground before I start. This is very important because we want to create first a digital elevation model, and normally you think of that as sort of a bare earth model. So the elevation of the earth without buildings, vegetation, and so forth. To get started making that DEM, I'm going to go to my conversion tools, and then the to raster toolbox, and the LAS dataset to raster tool, which we will be using that same tool repeatedly in this tutorial. So we're going to use our input as our Hopkinsville dataset, and then we're going to name our output raster. This one I'm going to name it elevation default because we're just going to run the tool using the defaults and see how that looks. Our value field is elevation, and that's going to stay the same every time that we run this tool. And under interpolation type, you can see it's set to binning. We're going to leave that for now. And then the next thing to look at is that cell size at the bottom. We're going to leave that default as well at 10 meters. So this is our default 10 meter elevation model using just ground returns. So let's try it again, and this time we're just going to change the cell size. So I should have renamed my data set there, but I forgot. Then under sampling value, that's the cell size of your output data set. So I'm going to change that to 1, so it'll be 1 meter squares. Now you can see this result is quite a bit smoother, has more detail to it than our 10 meter data set. So for the remainder of this tutorial, make sure you use that 1 meter cell size at the bottom of the tool. So next we're going to be looking at changing the interpolation type, and you can get more information on these types from the help. We are going to start by changing our void fill method to natural neighbor, and again using that cell size of 1. And our final result, you can see I'm zoomed in here to this water body, gives us a much more smooth appearance across water bodies than those linear methods. So next we're going to go through and name your new data set again, and this time under interpolation type we are going to go to the triangulation menu, and we'll just leave everything else as default, cell size 1. You can see this gives us again kind of a more linear blocky result, and then we'll try running that one more time under the triangulation interpolation type menu, but with using natural neighbor. You can see this gives us a little bit more of a smooth appearance, but different than the natural neighbor that we did previously. So if we wanted to compare these different DEMs that we've created side by side, we can go to the image analysis window. I'm going to move my window over so you can see the changes in the DEM, and we're going to be using the swipe button. So once you've selected one of your images at the top of that menu, you can use the swipe button to see what's directly underneath it, the layer directly underneath it, just by sliding and holding. So next thing we're going to do is create a digital surface model. So for this we're going to be using our first return as our filter before we run the same tool, LAS dataset to raster. And again, your book goes into more detail about DSM or digital surface models versus DEM. We're just going to run this under elevation again, because again we've already set those filters, so it's going to be using those first returns. And we're going to use natural neighbor as our void fill method and a sample size of 1. And our DSM, you can notice right away, looks pretty different from our DEM. Let's zoom into this area here that looks to have quite a bit of vegetation as well as buildings. And I'm going to compare that DSM that I just created with the corresponding DEM, the one that used natural neighbor, and using that swipe button, and you can see the difference there. So lastly, we're going to be going to spatial analyst tools, and this is going to be working with our DEM, not our DSM, which is currently showing. We're going to be creating some different surface raster. So first we're going to create aspect from that natural neighbor 1 meter DEM. When it's added to our map, I'm going to zoom out to our full extent. You can see there I've got my aspect, And then in the same way, I can run other tools that make surfaces such as hillshade, slope, contour. You can see I sped up the sequence here, but I went ahead and created all of those different surfaces from that initial DEM. And these surfaces are ones that can be used for analysis rather than simply symbology, which is what we looked at in earlier tutorials. This video was produced by Virginia View, a consortium dedicated to promoting remote sensing outreach, education, and research, with funding from the America View Consortium, in partnership with Virginia Geospatial Extension and GeoTED.